Okay, so in this example, we are going to talk about the two-way analysis of variance, which is a type of factorial ANOVA. So let me explain this to you. You see the example there on the screen. Don't pay attention to that yet. You're probably reading that right now, but you should be listening to me. So let me explain a little bit about the factorial ANOVA. The factorial ANOVA, in this example, it's going to be what's called a two-way ANOVA. What that means is that you have two independent variables, okay? And each independent variable must have at least two levels. So in a 2x2 ANOVA, you have two independent variables with two levels. You could also have a 2x3 ANOVA. So in the case of a 2x3 ANOVA, your first independent variable would have two levels, and your second independent variable would have three levels. You could have a 3x3 ANOVA, okay, which means that you have two independent variables, each with three levels. So in order for let me put it this way: the most basic ANOVA that you can conduct is a 2x2. So in order to conduct a factorial ANOVA, you have to have two independent variables, and they each have to have at least two levels. There's more information on Canvas about the design, and there's an example up there that you can look at. Also, the two-way ANOVA is going to yield what's called two main effects and two main effects and one interaction term, and I'll explain that in more detail. So also the analysis of variance, the ANOVA, the factorial ANOVA, can be within subjects or between subjects, or also it could consist of a mixed design where you have a between subjects factor, an independent variable that's between subjects, or an independent variable that is within subjects. So in this particular example, this will be a 2x2 between subjects ANOVA. Okay, so here's our example. A psychologist wants to study the effects of alcohol on reaction time between males and females. Males and females, okay, that is one independent variable with two levels. Okay, sex and male and female, those are our two levels. They're split into separate groups, and then within each group, the participants are given either 6 non-alcoholic beers or 6 real beers. So again, we want to study the effect of alcohol on reaction time as a function of sex. Their data are summarized below. The higher the score, the worse the reaction time. What can you conclude? So you see that we have a 2x2 factorial design. And actually, let me write it here. This is how you would write it. Oops, sorry. Okay, that's how you would properly write the design of your study in APA format. So you can see that we have one independent variable which consists of sex, and there's two levels, male and female. We have another independent variable, that's the amount of alcohol consumed, control versus 6 beers, those are our two levels. And then our reaction time score, this will be a continuous variable, a scaled variable. The higher the reaction time score, the worse the reaction time. So you can see that we have two independent variables with two levels. You want to know how many groups you have? Just multiply your factors. 2x2 equals 4, and you can see here that we have 4 groups. Okay, males in the control group, females in the control group, that get 6 beers, and females that get 6 beers. And then we have their scores for each group. Okay, now conceptually, and actually, these are the data we're going to be working with. They're summarized here. Conceptually, what the ANOVA is doing is it is comparing all combinations of all independent variables. So this right here is the score, the reaction time score for men in the control group, right here, and the reaction time score for men that have 6 beers. And then their score, and the analysis of variance will average their score together. Here we have women in the control group and women who receive 6 beers, and it will average their scores together. Here we have men in the control group, women in the control group, and it will average their scores together. You have men who receive 6 beers and women who receive 6 beers, and it will average their score together. So this illustrates the main effects of sex and alcohol. So the difference, these two means right here, 9.78, this is the average of 4.28 and 15.28. Okay, you average those together, you get 9.78. Okay, same thing. Average these scores together. Here's the average. So what the analysis does is it compares the average score for men with the average score for women, holding the amount of alcohol constant. Okay, so it's just looking at the scores for men and the scores for women, holding alcohol constant. That is the main effect for sex. Okay, similarly, we have a main effect for alcohol. It's looking at the average of the control group participants, comparing it to the average of participants that receive 6 beers, and it's looking for a mean difference between these groups. That is the main effect for alcohol. Okay, and then so those are your two main effect terms, and then it also computes an interaction term, and that will become more clear in a minute, but just by looking at these data, you can see that one cell here is much higher than the others, indicating that there's a significant interaction. And again, that'll be more clear when we go through the data. Okay, so real quick before we look at SPSS, recall that we have 4 groups. Okay, these are our 4 groups, and here are our data. So let's go to SPSS, and the way you set up the data file for a factorial ANOVA is you are going to have one column for each independent variable in your study. So in our study, we have 2 independent variables, sex and alcohol, or here I have it called group. So you have 2 independent variables. And then our final column of data is going to be the scores for each person in each group. So I have, under variable view, I have sex, and I have defined males as 1 and females as 2. For my grouping variable, 1 is the control group that receives no alcohol, and 2 is the treatment group that receives 6 beers. Okay? And those 2 are both nominal variables, and our dependent variable, which is score, is a scaled variable. So your first 2 columns of data demonstrate different combinations of the variables. So just for example, we gave men a 1 and females a 2. And for our grouping variable for alcohol, a 1 was the control group and 2 was the treatment group. So you can see that the first participant is a male who was in the control group, and they scored a 3. If we scroll down here, we see that we have a female who's also in the control group, and they scored a 1. Scroll down further, you see that we have a male who's in the treatment group, and they scored a 12. Further yet, we have a female who's in the treatment group, and she scored a 3. So again, these first 2 columns are telling the computer, telling SPSS, which participant is in which group. So we have men in the control group, we have women in the control group, we have men in the treatment group, and we have women in the treatment group. Okay, so this data file reflects our 2x2 factorial design. Okay, so let me show you how to actually run the analysis. You're going to go to Analyze, General Linear Model, and go to Univariate. Okay, we're going to bring score over, or we're going to bring our dependent variable over to the dependent variable box, and our fixed factors are our 2 independent variables. Okay. we are simply going to go to options, and we are going to bring over the overall means and also the means for the interaction term, and click on descriptive statistics and click continue and then click OK. And here we go. So here are our descriptive statistics. So obviously males who are in the control group, their mean is 4.28. Males in the treatment group, their mean is 15.28. And then the total score for men collapsing across whether they're in the control or the treatment group is 9.78. Similarly, we have females in the control group 3.14, females in the treatment group 2.71, and the average score of females regardless of their group is 2.93. And then we have the total for the control group and the total for the treatment group. Okay, so those are all your means, and that was reflected in this table right here. Okay, that's exactly where I got these means from. Let's look at the actual output, the test of the between subjects effect. If you look at sex and you follow that over here, we see an F value of 75.13. So we have a significant main effect of sex. If you look at group, it has an F value of 4.64. So we have a significant main effect of group, alcohol versus no alcohol. And then here's our interaction term, sex by group, that little star there, that's the symbol for the interaction term. Sex by group, we have a significant interaction. Okay, now typically, when you have a significant interaction, you don't worry too much about the main effects because explaining the interaction explains the nature of the main effects. So let me show you exactly how the interaction term works, and to conceptually understand the interaction essentially means that it depends. Okay, so is there a effect of alcohol on reaction time? Well, basically the answer is it depends on if you're a man or a woman. That's essentially what the significant interaction term is indicating. Alternatively, you could say, is there a difference between men and women in terms of reaction time, the effect of alcohol on reaction time? And you could say, well, it depends on how much alcohol you get. So it's often very helpful to graph interactions. And let me show you quickly how to do that. And this graphing the interaction will help you interpret it. So I simply went to graphs here, went to chart builder, clicked OK. That's just saying you need to define your variables, which I've already done. I'm going to go to line, and this multiple line graph option, I'm going to drag that up here. Okay. For score, this is my dependent variable. I'm going to bring this to the y-axis. For sex, I'm going to bring this to the up here where it says set color. And then for the grouping variable, I'm going to bring that to the x-axis. Okay. I want to make sure that under my element properties, my statistic is on mean. And I'm going to click OK. Okay. So what you see here is graphed here is a significant interaction. So for control group participants, and actually there's a better way to do this. I'm going to go to graphs, chart builder, and I'm going to bring group up here, and I'm going to bring sex down here. That makes it a little easier for me to interpret. Okay, so what you see here is down here at the bottom, you've got males and females. The green line is the treatment group, and the blue line is the control group. And on the horizontal axis here, we see the mean reaction time score. And you'll recall that the lower the reaction time score, the better. So for males in the control group, they scored significantly better than when they were in the treatment group and they received 6 beers. Okay, so there's a big difference here between men as a function of alcohol on their reaction time score. But for females, okay, there's no significant difference between groups for the control group and the treatment group. So what this is telling us is that there's a difference in reaction time for men, but not for women. So in other words, alcohol is affecting reaction time for men, but there is not an effect of alcohol on reaction time for women. And that is the nature of your interaction. If you want to think about, does alcohol differentially affect reaction time for men and women? The answer is yes. Okay, alcohol is significantly impairing men's reaction time, but it is not impairing the reaction time for women. Okay, now this is a hypothetical example. In real life, I'm 100% certain that you wouldn't find this effect, but I think it's demonstrative for our purposes today. Okay, so let's go to, so again, that's how you interpret the interaction effect here. Let's go to the write-up of the properly formatted APA answer. Okay, here I provide just a short synopsis of the design. Okay, a 2 by 2 factorial was conducted to study reaction time differences between men and women as a function of the amount of alcohol consumed. There's many different ways that you could say that, but the idea here is that we're looking at the effect of alcohol and reaction time as a function of sex. So here I report that there was a significant main effect of sex, okay, such that men had a significantly lower reaction time than women. There was also a significant main of alcohol, such that when 6 beers were consumed, reaction time was significantly lower than when no alcohol was consumed. Now, typically, again, when you have a significant interaction, you really don't have to go into all this stuff about the main effects. But it can be helpful depending on the context. But here I report the interaction term. There was a significant interaction indicating the effect of alcohol on lowering reaction time was significantly greater for men than it was for women. Okay, so that is basically how you conduct and interpret a two-way factorial analysis of variance when there's a significant interaction term. Now, you won't always have a significant interaction term. You could have one significant main effect and no significant interaction, or you could have two significant main effects and no interaction, or you could have nothing be significant. Typically, the interaction is interesting. That's much more interesting than having one main effect or two main effects, depending on the research question. Most of the time, the interaction is more interesting because the interaction is essentially saying, well, it depends. In this example, we did have a significant interaction, but again, you won't always. Okay, so look over the video, look over the research, all the material posted on Canvas, and I think that there's enough information in here to help you understand how to conduct a two-way analysis of variance.